We're going to briefly go into 5.4 today. We kind of touched on it as we went through substitution, elimination, and graphing, but on page 148 of your student journal, I want you to complete number 4 there. Okay? Work with your groupies there, page 148. All right, Quentin, what do you got?
Actually, I left my book at home and I was going to ask if I could go use it.
No, let's do this first. So how many solutions here? One solution. Okay? The majority of our answers have had one solution where the two lines cross. How many solutions on this one?
None.
No solutions. If the lines don't cross, you don't have any solutions. How many solutions if they share all points? Infinitely many. All right. Infinitely many. So pictorially, that's what happens. Now, the thing that we need to take a look at is graphically, or not graphically, but equation-wise what happens. So I want you to take a look at page 150. On page 150, we have a few different problems. I want you to start with problem number 1, please. Okay, number 1, go ahead and solve that. Okay, number 1. Number 1, if I use substitution, or not, well, I could use substitution here. I could also use elimination. I could just make all the bottoms negative, okay, by multiplying by -1. Notice this disappears and that disappears. I'm left with what on this side of the equation? Nothing. And over here? What's -7 and -4? -11. Okay? Not -3. -11. Does 0 equal -11? No. So if you're solving an equation, a system of equations, and you end up eliminating all of your variables and you get a false statement, this is never true. 0 does not equal -11. This is no solution. What type of lines are those?
Parallel.
They're parallel. What do you know about parallel lines and their slope?
Same slope.
Okay, so you could have just looked at y equals mx plus b form to begin with, and notice the slopes are the same. So if the slopes are the same and you recognize they're parallel, okay, different y-intercepts, then you could have just said no solution there as well. All right, try number 3, please. Number 3. All right, well, let's check this one out. If I add them up, since I have opposites, that's 0, that's 0, that's 0. On this side, I get 0. On this side, I get 0. That is infinitely many. Your variables disappeared, and you're left with a true statement. Infinitely many solutions. Infinitely many. I prefer you do infinitely many. Infinitely many. Okay, so go ahead and tell your neighbor how, in an equation, how do you know if it's no solution or infinitely many? We know what it looks like in a picture. How about equations? Okay, volunteer. How do we know? Yes, sir. Good. If you get rid of your variable and they don't equal each other, it's no solution. Can't be true. If you get rid of your variable and they equal each other, that's infinitely many. Any questions? Okay, one more problem here and then we'll be off on today's stuff. Number 19. Give it a go. Okay, you have 15 in savings. Your friend has 25. You both start saving 5 per week. Write a system of linear equations that represents the situation will you ever have the same amount? So if you save 5 per week, both of you, this is you, this is your friend, what's your rate? 5. Okay? 5x. 5 per week. If x equals numbers of weeks, what's y going to be?
Total.
Yeah, total saved. Okay, so if that's the case, you have 15 in savings already. What do we have to do to our 5x that we've already, or that we're saving? Add 15. That's going to be our total. And how about your friend?
Add 25.
Add 25. That's going to be your total. Are you ever going to have the same amount?
No.
Why not? Parallel lines. Save at the same rate. Parallel lines, you'll never have the same amount. All right, good job.